The title slide sets the stage for the presentation Understanding Gravity with the subtitle Exploring the Force That Shapes Our Universe, highlighting the central theme and significance of gravity in shaping the cosmos. Designed for a diverse audience, ranging from students to enthusiasts, the presentation aims to provide a comprehensive exploration of gravity's fundamental principles and its profound implications for the universe's structure and dynamics. Structured to cover various aspects, from an introduction to gravity to discussions on its force, mass versus weight, gravity on different planets, gravity on the Moon, and its role in orbits and the universe. The presentation is accompanied by relevant visuals depicting celestial bodies and gravitational interactions. By the end, attendees will gain insights into the basic principles of gravity, its influence on celestial bodies and everyday life, and its importance in advancing scientific knowledge and exploration, setting the stage for an engaging and informative exploration of this captivating topic. Introduction to Gravity. Gravity is the force that pulls objects towards each other. It's what keeps our feet firmly planted on the ground and causes things to fall down when we drop them. This force is essential for understanding many aspects of the universe, from the motion of planets and stars to the behavior of everyday objects on Earth. Gravity plays a crucial role in shaping our understanding of the cosmos, influencing everything from the structure of galaxies to the formation of black holes. Force of gravity. The force of gravity is determined by the masses of the objects involved and the distance between them. Sir Isaac Newton's law of universal gravitation describes how the force of gravity between two objects depends on their masses and the distance separating them. This law states that every mass attracts every other mass with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. For example, the force of gravity between the Earth and an object near its surface can be calculated using the object's mass and the mass of the Earth, as well as the distance between them. Mass versus weight. Mass is a measure of the amount of matter contained in an object, while weight is the force of gravity acting on that object. Mass is an intrinsic property of an object and remains constant regardless of its location, whereas weight varies depending on the strength of the gravitational field. Mass is measured in kilograms, while weight is measured in newtons. On Earth, the force of gravity is approximately 9.8 newtons per kilogram of mass. However, weight can change if an object is moved to a location with a different gravitational field, such as another planet or the Moon, while its mass remains the same. Understanding the difference between mass and weight is essential for various scientific calculations and everyday applications. Gravity on different planets. The strength of gravity varies from one planet to another depending on its mass and size. Each planet has its own gravitational force, which determines how much objects weigh on its surface. For example, Jupiter, the largest planet in our solar system, has a much stronger gravitational pull than Earth, making objects weigh more on Jupiter's surface. Conversely, smaller planets like Mars have weaker gravitational forces, resulting in objects weighing less than they do on Earth. Understanding the differences in gravity between planets is crucial for space exploration missions and understanding the conditions on other celestial bodies. Gravity on the Moon. The Moon has significantly less mass than Earth, resulting in weaker gravity on its surface. Despite being much smaller, the Moon still has enough gravity to keep objects on its surface and to orbit around Earth. Because the Moon has only about 1/6 of the Earth's gravity, objects weigh much less on its surface compared to Earth. For example, a person weighing 60 newtons on Earth would weigh only 10 newtons on the Moon. This difference in gravity has profound effects on the behavior of objects and the conditions experienced by astronauts during lunar missions. Gravity and orbits. Gravity plays a crucial role in the motion of celestial bodies, such as planets, moons, and satellites, within the solar system. The gravitational force between two objects causes them to attract each other, resulting in orbital motion. Johannes Kepler's laws of planetary motion describe how objects move in elliptical orbits around a central mass, such as the Sunday gravity keeps planets in their orbits around the Sun and moons in their orbits around planets. Understanding the relationship between gravity and orbits is essential for predicting the motion of celestial bodies and planning space missions. Gravity's role in the universe. Gravity is not just limited to the interactions between planets and moons, it also shapes the entire universe on a grand scale. Gravity is responsible for the formation of stars and galaxies. In the early universe, gravity caused clouds of gas and dust to collapse, leading to the formation of stars. These stars then grouped together under the influence of gravity to form galaxies, which are held together by the combined gravitational pull of their constituent stars, gas, and dark matter. Moreover, gravity plays a crucial role in phenomena such as gravitational lensing, where the bending of light by massive objects allows astronomers to study distant galaxies and dark matter distribution. Additionally, theoretical concepts such as black holes, regions of space with extremely strong gravitational fields, and gravitational waves, ripples in spacetime caused by the acceleration of massive objects, further illustrate the profound impact of gravity on the universe's structure and evolution. Applications of gravity. Beyond its role in astrophysics, gravity has numerous practical applications in everyday life and various fields of science and engineering. Gravity is crucial for transportation systems such as elevators, escalators, and roller coasters, where it determines how they operate and how they keep passengers safe. Furthermore, gravity plays a vital role in engineering and construction, influencing the design and stability of structures like bridges, buildings, and dams. Additionally, technologies such as GPS, global positioning system, and satellite communication rely on an accurate understanding of gravity to function effectively. Understanding the principles of gravity and its applications allows scientists and engineers to develop innovative solutions and improve various aspects of modern life. Conclusion. In conclusion, gravity is a fundamental force that governs the behavior of objects in the universe, from the smallest particles to the largest celestial bodies. Understanding gravity is essential for explaining the motion of planets, stars, and galaxies, as well as for predicting the behavior of objects on Earth and in space. The study of gravity has profound implications for our understanding of the universe's structure, evolution, and dynamics. By unraveling the mysteries of gravity, scientists and engineers can develop new technologies, explore new frontiers in space, and gain deeper insights into the nature of the cosmos. As we continue to explore and study gravity, we unlock new discoveries and innovations that shape our understanding of the universe and advance human knowledge and exploration. Title slide. This slide introduces the topic of transfer of energy. The title Transfer of Energy highlights the main theme of the presentation. The subtitle Understanding How Energy Changes Forms provides a brief overview of what the audience can expect to learn. Including the presenter's name or organization adds a personal touch and helps establish credibility. This slide serves as an introduction and sets the stage for the rest of the presentation. Introduction to energy. Energy is like a superpower that lets things happen. It's what makes things work, like turning on a light or ringing a doorbell. When we use energy, it can change from one form to another. For example, when you turn on a light bulb, electrical energy changes into light and heat energy. So, energy can transform and do different things. Forms of energy. There are many types of energy around us. One type is electrical energy, which powers things like our TVs and phones. Sound energy is what makes noise, like music or someone talking. Light energy comes from sources like the sun or a light bulb, helping us see things around us. Heat energy is what keeps us warm and makes things hot, like a cozy fireplace or the sun on a sunny day. Energy transfer examples. Let's look at some examples of how energy changes from one form to another. When you press a doorbell, electrical energy travels through wires and changes into sound energy, making the bell ring. Your TV changes electrical energy into both sound and light energy so you can hear and see your favorite shows. Even a simple light bulb changes electrical energy into light and heat energy, brightening up a room while giving off warmth. So, energy can change forms to do different jobs for us. The sun as the ultimate source. The sun is like a giant battery in the sky, giving us energy in the form of light and heat. It's the ultimate source of energy for life on Earth. Every day, the sun shines down on us, providing warmth and helping plants grow. Without the sun, Earth would be dark and cold, and life as we know it wouldn't exist. So, the sun is incredibly important for keeping our planet alive and thriving. Energy from the sun. Did you know that energy from the sun powers almost everything around us? Plants, trees, animals, and even humans rely on the sun for energy. Through a process called photosynthesis, plants use sunlight to make their own food, which then becomes energy for animals and people when they eat them. So, the sun's energy is essential for keeping the entire ecosystem running smoothly. Importance of sunlight. Sunlight is like the lifeblood of our planet. It reaches Earth in just 8 minutes, providing light and warmth that sustains life. Sunlight helps plants grow, which in turn provide oxygen for us to breathe and food for animals to eat. It also regulates our climate and seasons, making Earth a comfortable place to live. So, we depend on sunlight for our very existence, and it's crucial to protect it for future generations. Using plant energy. Plants are like nature's energy factories. They use the energy from sunlight, along with water and carbon dioxide from the air, to make their own food through a process called photosynthesis. This food isn't just for the plants themselves, it's also the starting point for the food chains that sustain all life on Earth. When we eat plants or the animals that eat plants, we're getting energy that originally came from the sun. So, plants play a vital role in providing us with the energy we need to live and thrive. Importance of reducing fossil fuel usage. While the sun provides us with clean and renewable energy, many of the ways we currently generate energy involve burning fossil fuels like coal, oil, and gas. This releases harmful pollutants into the air, leading to air pollution, climate change, and other environmental problems. To protect our planet and ensure a sustainable future, it's crucial to reduce our reliance on fossil fuels and transition to cleaner, renewable energy sources like solar and wind power. By doing so, we can help preserve the environment for future generations and create a healthier planet for all living beings. Conclusion. Understanding how energy moves and changes forms is essential for us to appreciate the world around us and make responsible choices for the future. From the simple act of turning on a light to the complex processes of photosynthesis, energy powers everything we do and is vital for sustaining life on Earth. By harnessing renewable energy sources like the sun and reducing our dependence on fossil fuels, we can protect the environment, mitigate climate change, and ensure a brighter future for generations to come.
Title: Changing Materials. Subtitle: Understanding how materials transform in different conditions. Introduction. This slide introduces the topic changing materials. It explains that we will be learning about how different materials transform or change under various conditions. Understanding how materials change is important because it helps us know how to use them effectively and safely. Materials changing with heat/cold. This slide discusses how materials react to changes in temperature, like heating or cooling. When materials are heated, they may expand or change from solid to liquid or gas. For example, ice melts into water when heated. Conversely, when materials are cooled, they may contract or change from liquid to solid. For example, water freezes into ice when cooled. Mixing materials. This slide talks about mixing different materials to create new substances. For example, when we mix sand, water, and cement together, we get a substance called mortar. Mortar is used in construction to hold bricks or stones together. Similarly, when we mix flour, egg, butter, and sugar together and bake it, we get a cake. Baking causes these ingredients to react and transform into a delicious treat. Chemical changes. This slide explains chemical changes that occur in materials. For instance, when paper is burned, it doesn't just change its state, it undergoes a chemical reaction, transforming into ash. The paper's molecules break down into simpler forms during burning. Another example is when we heat an egg. The heat causes the egg's proteins to denature, leading it to become hard instead of staying liquid. Environmental changes. Here, we discuss how environmental factors can affect materials. For example, when iron nails are exposed to moisture and oxygen in the air, they undergo a process called rusting. Rusting causes the iron to change into a reddish-brown substance known as rust. Understanding these environmental changes is essential for preserving and protecting materials in various situations. Applications and uses. This slide talks about the practical applications of understanding material changes. Knowing how materials change is crucial in many fields, such as construction, cooking, and environmental science. For instance, builders need to understand how different materials react to temperature changes to construct durable structures. Cooks use their knowledge of ingredient reactions to create delicious dishes. Environmental scientists study how materials degrade or decompose in nature. Conclusion. This slide summarizes the key points discussed throughout the presentation. It emphasizes the importance of studying changing materials for various applications and fields. It also encourages further exploration and experimentation to deepen our understanding of how materials change.
Title: Magnets. Subtitle: Exploring the World of Magnetism. This slide introduces the topic of magnets. Magnets are objects that have the special ability to attract certain materials like iron, nickel, and cobalt. We'll be diving into the fascinating world of magnetism in this presentation. Introduction to magnets. Definition of a magnet. A magnet is an object that produces a magnetic field around itself, causing it to attract certain materials. Historical background. Brief. Humans have been fascinated by magnets for thousands of years. Ancient civilizations discovered naturally occurring magnets called lodestones, which were used for navigation. Importance of magnets in everyday life. Magnets are used in a wide range of applications, from household items like refrigerator magnets to complex technologies like MRI machines in hospitals. Properties of magnets. Able to attract magnetic materials. Magnets can attract materials like iron, nickel, and cobalt. This property is called magnetism. Have two poles, north and south. Every magnet has a north pole and a south pole. Like poles repel each other, while opposite poles attract. Broken parts of a magnet also have two poles. If you break a magnet into smaller pieces, each piece will still have a north and south pole. Magnetic compass. Explanation of how a magnetic compass works. A magnetic compass is a simple device that uses a magnetized needle to point towards the Earth's magnetic north pole. This helps navigators determine their direction. Law of magnetism. Overview of the basic principles of magnetism. The law of magnetism states that like poles repel each other, while opposite poles attract. This fundamental principle governs the behavior of magnets. Explanation of the law of magnetic poles. According to this law, every magnet has two poles, north and south. Similar poles repel each other, while opposite poles attract. Magnetic fields. Definition of a magnetic field. A magnetic field is an invisible area around a magnet where its magnetic force is exerted. It's like an invisible force field that surrounds magnets. Visualization of magnetic field lines. Magnetic field lines help us visualize the shape and strength of a magnetic field. They flow from the North Pole to the South Pole, forming closed loops. The Earth's magnetic field. Explanation of Earth's magnetic field. The Earth behaves like a giant bar magnet with a north and south pole. This magnetic field extends from the Earth's interior out into space, protecting our planet from harmful solar radiation. How the Earth behaves as a giant bar magnet. Just like a regular bar magnet, the Earth's magnetic field has north and south poles. This magnetic field influences compass needles and helps birds and other animals navigate. Effects of Earth's magnetic field. Navigation and the use of magnetic compasses. The Earth's magnetic field is crucial for navigation, especially for sailors and explorers who rely on compasses to find their way. Protection from solar wind and cosmic radiation. The magnetic field acts as a shield, deflecting charged particles from the sun and cosmic radiation, protecting life on Earth. Applications of magnets. Magnetic levitation. Magnets can be used to levitate objects, like maglev trains that float above magnetic tracks, reducing friction and allowing for faster travel. Magnetic resonance imaging, MRI in medicine. Magnets are used in MRI machines to create detailed images of the inside of the body, helping doctors diagnose and treat various conditions. Conclusion. Summary of key points covered. Throughout this presentation, we've explored the fascinating properties of magnets, from their ability to attract certain materials to their role in navigation and technology. Importance of understanding magnetism. Understanding magnetism is essential for various fields, from science and technology to everyday life.